Now, moving forward, our problem statement is comparative analysis of various machine learning classification algorithms and development of a web based malware scanner. So, moving forward with the topic, in this study, we aim to conduct a comprehensive comparative analysis of diverse machine learning classification algorithm. Our primary objective is to evaluate and compare the performance of these algorithms across various metrics such as accuracy, precision, etc. This malware scanner will be designed to detect and mitigate malicious software on the web, ensuring the security of online users. The insights gained from our comparative analysis will guide the development of this essential cybersecurity tool, enhancing web safety for all. This scanner's primary mission is to proactively detect and neutralize malicious software entities lurking within the vast expanse of the web. Given the ever evolving nature of cyber threats, an effective malware scanner is indispensable in safeguarding the online security and privacy of users. In today's digitally interconnected world, the internet has become an integral part of our daily lives, facilitating communication, commerce, and information exchange on an unprecedented scale. However, this digital landscape is not without its risks, as it harbors an array of malicious software, commonly known as malware, that poses a significant threat to our online security and privacy. Malware encompasses a wide spectrum of harmful entities, including viruses, worms, trojans, spyware, ransomware, and more. These insidious programs are designed with malicious intent, seeking to exploit vulnerabilities in computer systems and compromise sensitive data, disrupt operations, or even gain unauthorized access to devices and networks. In response to the ever evolving sophistication of malware, the field of cybersecurity has evolved in tandem, with one of its core components being malware detection. Malware detection is a proactive and vital security measure aimed at identifying and mitigating the presence of malicious software within digital environments. Moving forward, now Sakshi will explain you the LR and all, which the books which we researched on while making this project. So Sakshi will take forward.
Now let's delve into the research papers which we have reviewed for our project. So now the first research paper titled A Comprehensive Review on Malware Detection Approaches. In this, the authors conducted an analysis and found that when it comes to the known malware, signature based and heuristic based detection methods perform quite effectively. However, for unknown and complex malware, behavior model checking and deep learning approaches prove to be more efficient. Nevertheless, it's worth noting that there are still certain aspects of malware that remain undetectable even with these advanced approaches. Therefore, the development of an effective malware detection method remains a highly challenging endeavor. Moving to the next research paper, which is titled as Advances in Computer Science for Engineering and Education. In this research paper, the authors suggested that there is still room for enhancing the mathematical foundations of malware detection systems by incorporating modern neural networks models, the particularly deep neural networks. This area holds promise for the further advancements of malware detection systems, and future research should focus on adapting these methods for the application of deep neural networks in behavior analysis. Now I'll move to the next research paper, which is titled as A Comparison of Static, Dynamic, and Hybrid Analysis for Malware Detection. The authors trained hidden Markov models and compared the detection rates for models based on static and dynamic data. Their findings revealed that for a broad spectrum of malware families, a dynamic approach based on API calls is highly efficient. But it's important to note that some portions of malware remain undetectable using static analysis methods. And it should be noted that utilizing a dynamic approach can be computationally extensive. And the next research paper, which is titled is Analysis of Machine Learning Models for Malware Detection. In this, the results of various classification algorithms are compared considering different analysis approaches. Both static and dynamic analysis showed recommendable detection rates. However, the dynamic analysis is resource intensive, demanding substantial time and computational power, as it requires running the file in a controlled environment. Additionally, the static analysis struggles to detect malware that employs obfuscation techniques. And the next research paper is Evolution of Malware and its Detection Techniques. In this research paper, a comprehensive discussion on second generation malware and malware detection techniques is presented. The article highlights the techniques such as malware normalization and machine or deep learning demonstrates high accuracy in detecting the previously unseen or unknown variants of malware. In contrast, the traditional malware detection methods like signature based and heuristic approaches struggle to detect the polymorphic and metamorphic malware, which employs the advanced obfuscation techniques. Now, further, Mohit will tell about the more research papers which we have reviewed.
Okay, so the next research paper that we referred to was the use of machine learning techniques to advance the detection and classification of unknown malware, authored by Ihab Shahadat and colleagues and published in 2020. The machine learning models can detect the unknown malwares, unlike standard malware detection techniques. The ML models also had higher accuracy in detecting malwares, but the disadvantages were the machine learning models may give less accuracy when the data was imbalanced, and also considering irrelevant features may reduce the model's accuracy. And then the next research paper that we refer to was the rise of machine learning for detection and classification of malware detection, authored by Daniel Gilbert and published in 2019. Static based approaches extract features derived from a piece of program without its execution, whereas in dynamic based approaches, we extract features from the execution of malware during the runtime, and hybrid approaches combine the static and dynamic analysis to extract the features. But the disadvantages were the model could be forced to make incorrect predictions if the malware writers used adversarial learning, and if the machine learning model is not trained on a good dataset, then the model can classify a malware to the wrong class. And then the next paper referred to was improving malware detection using big data and ensemble learning, and authored by Deepak Gupta and published in 2020. So in this paper, the authors have designed two methods based on ensemble learning and big data for improving the performance of malware detection at a large scale. The experimental results show that the proposed scheme based on weighted voting provides the highest accuracy of 99.5%. However, the disadvantages were in the present work, only the balanced data set were taken for simplicity. In general, the malware detection and classification problem is a class imbalance problem which includes far more instances of benign classes than the malicious classes. And then the next paper that we referred to was a real-time PE malware detection system based on chi-square test and PE file features, authored by Mohammad Baloud and published in 2015. The proposed work uses an efficient feature selection method which is based on the chi-square test, and this allowed to achieve a higher accuracy and a low detection time using only 2% of the initially extracted features. However, the disadvantages were the features such as API calls and opcode are not taken into consideration. And then the last feature paper that we refer to was a learning model to detect maliciousness of portable executable using integrated feature set, authored by Ajit Kumar and published in 2017. This paper proposed a feature engineering technique known as integrated feature set, which improves the accuracy of existing classifiers built on PE headers values. But the disadvantages were in the paper, malware and benign samples application type information is not taken into consideration. Now, Palak will continue with the methodology of the paper. Now I'll pass on to her.
Moving on to the methodology, let's first talk about how we will detect the malware in the executable files. So, after reading a number of previous researches, we figured out that we can use portable executable or PE file for the same. So, the PE format is a file format for executables, object code, DLLs, and others used in 32-bit and 64-bit versions of Windows. So the PE data structure contains various parts like the DOS header, DOS stub, image optional headers, and others, and more, like which can be analyzed to detect any malicious activity or code. So now moving on, after a bit of research with this, we found that there are two types of analysis that can be performed for the malware detection. Stat- First static and then dynamic. So static malware analysis involves inspecting the file header, metadata, strings, resources, and code of a suspicious file by using some specific tools for the same. Static malware analysis can reveal the file type, size, version, checksum, and other things. So, also it can also detect obfuscation and encryption techniques that the malware uses to hide its true nature. However, dynamic malware analysis is a technique that involves that executes the malicious file in a simulated or isolated environment and monitors its behavior and effects. It can also use the tools like virtual machines, sandboxes, emulators, debuggers, and others to observe the file's actions and interactions. So for the malware detection, we have planned to implement it as follows. We will use the dataset taken from Kaggle, pre-process it and remove the rows with empty entries. Moving further, we will then analyze the executable files for the malware by static and dynamic analysis. However, for this project, we will just perform the static analysis by analyzing the PE files for the malware. Then we will perform feature extraction and provide the features that thus is extracted for the training of the models. We will train a number of machine learning models with the above data, and then we will test the all of the models with some testing data that will be taken from the dataset itself. And based on the testing, the accuracies for each of the models will be calculated. Also, we have planned to use the following models. First will be decision tree. It has a simple tree-like structure. This model makes a decision at every node, and due to its easy explainability, it's easy to show how a decision process works. Gradient boosting. When training this type of model, there is a series of small decision trees in which each tree attempts to correct errors from the previous stage. The learning rate controls how hard each new tree tries to correct remaining mistakes from the previous one. Then KNN. KNN is K nearest neighbor, which is a supervised learning algorithm in which we classify the test data points on the basis of the votes of K nearest neighbors. There is no learning or training done in KNN. Logistic regression, the statistical analysis method which is used to make predictions for data value based on prior observations from a data set, is called logistic regression. Uh, the relationship between one or more independent variables is analyzed by this model, and on the basis of its analysis, it predicts a dependent data variable. Then random forest, a popularly used effective method in machine learning. It requires creating models known as ensembles, and an ensemble considers individual learning models and combines them to further make an aggregate model that is more powerful. A random forest is an example of this idea applied to decision trees. XGBoost classifier. XGBoost is an application of decision trees which are gradient boosted and designed for speed and performance. It uses multi-thread processing in order to search in parallel for the best division among the features. XGBoost performs really well in compared to other GBM implementations. So now Ambikesh will let you through the automation of the model.
So automation of model. So after training various models on a data set, we will save the model which gives the best accuracy on test data using the pickle module in Python as a .pkl file. We will then make a Python script which extracts the features of any given file using the p file module and use the pickle model which we saved to determine whether the file is malware or not. We would also upload additional files to test the performance of the model in classifying files. If the model outputs 0, it indicates that the file is marked as safe according to the model. Conversely, if the model outputs 1, it indicates that the file is classified as malware by the model. After testing, we may not get accuracy that meets our expectations, so we plan to enhance our dataset by including more data points in the training dataset. Uh, Extending the project to a website, we thought of making a website for our project that is open for all, where one could upload any executable file and check if that file is malware or not. We thought of using a JavaScript based stack for the development of the malware scanner, React.js and all. We'll first make a home page and add a form for taking the input file and uploading it on the server. The automation Python script that we made will take in the file path as an input and run the model and return its verdict as a string. The strings would be malware or banin. Now what we would do is check the string. If the string is banin, we would render an HTML page which will display the verdict as safe on the screen, and if the string is malware, we would render an HTML page which would display the verdict malware on the screen. That is, the file you have uploaded is not safe. So that is it. Thank you.